Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry mole concept. Come on, let us discuss few more questions from this session here. The first question here, the sample of calcium carbonate CaCO3 has the following percentage of composition: calcium 40%, carbon 12%, oxygen 48%. The law of constant proportion is true. Then the mass of calcium in 4 gram of a sample of calcium carbonate obtained from another source will be. Okay, now here mass of calcium present in that sample, as they have given the data, let us identify. So according to that, what it is? Calcium, according to the data, it is calcium 40% and carbon 12%, and oxygen, how much? Oxygen, it is 48%. Right now, in that sample, mass of calcium present in the sample, it is mass of calcium present in the sample. How much? Sample, how much? It is actually 4 gram. Now, how to find that mass of calcium in that compound? How much it is there? Okay, so mass of calcium equal to, so here mass of calcium, that is what the question they are asking, mass of calcium present in the sample, right? So here mass of the sample into percentage of calcium only they are asking, right? Some percentage of calcium divided by 100, right? So this is the formula we are going to use so that it will be easy for us to get the answer. This is a simple way for us to identify the answer. So mass of calcium, so mass of total mass of the calcium, how much? Here mass of the sample, it is 4 gram, and the percentage of calcium present in that compound, it is 40 divided by 100. So when you calculate it, you will be getting around what it is, 4 gram into 0.4. So you will be getting what it is, 1.6 gram. So 1.6 gram of calcium present in that sample what they have provided. So mass of calcium in 4 grams of calcium carbonate. Okay, mass of calcium present in 4 grams of calcium carbonate. So 4 grams of calcium carbonate, how much it will be remaining? That means calcium, how much it will be there? 1.6 gram you will be having. I hope you got that idea. Right now, which is the correct option? You know how to deal this sum, right? Okay, so 1.6 is the correct option, right? So 1.6 gram, yes, we got it. So 1.6 is the correct option. Option C is the correct option. I hope you got the clarity. Come on, let's go to the next question. The next question, the law of multiple proportion is illustrated by two compounds, that is sodium chloride and sodium bromide, ordinary water and heavy water, caustic soda and caustic potash, sulfur dioxide and sulfur trioxide. Okay, come on, let us go and deal this sum. This here, and this first one, sodium chloride and sodium bromide. No, so let me write that formula so that it will be easy for us to identify the answer. Sodium chloride and sodium bromide, and ordinary water and heavy water, and caustic soda NaOH and caustic potash KOH, and sulfur dioxide, sulfur trioxide. So in that, here fixed mass is there, I agree for it. But when we are going for that multiple proportion, here chlorine and bromine totally vary. So this will not be the correct option for multiple proportion what we are going to go through. And the same way, heavy water and ordinary water, hydrogen isotope only deuterium, but still it is vary. So this also will not be the correct option. And sodium and potassium, totally different atoms. So this also is not correct option for multiple proportion. Whereas here sulfur and sulfur, it is a fixed mass. Yes, and oxygen O2 and O3. So this is multiple proportion. So here when we are talking about 32 is to 32 atomic mass, and the same way here when we are talking about this 32 is to 48. So the ratio 1 is to 1, no, 2 is to 2, 2 is to 2, and the same way 2 is to 3. Right now here in this point, so here actually what it is, this is a fixed mass, whereas this is actually increasing. So the multiple proportion, so the number of atoms are increasing. In that way we can, the same way we have gone through, no, H2O2 and ordinary water, H2O and H2O2. So in that way we can consider, right? Okay, the same way PCl3, PCl5 in that. So there are so many examples for multiple proportion. I hope you got that idea. Now, which is the correct option? According to that, option D is the correct option. Sulfur dioxide and sulfur trioxide is the multiple proportion example. And other two also what I have mentioned, you can utilize that example also. Right? Come on, let us go to the next question. To one, all the substances listed below are fertilizers that contribute nitrogen to the soil. Which of these is the richest source of nitrogen on a mass percentage basis? Okay, now in this point, mass percentage we are going to calculate it. So how to calculate that mass percentage? Okay, now here mass percentage. So mass percentage, how to calculate means any of the substance. Now, for example, ammonia, it is very simple. Now we can take it NH3. So NH3 in that nitrogen, how much is available means here atomic mass of nitrogen, atomic mass of nitrogen. So nitrogen only we are going to calculate it. So atomic mass of nitrogen divided by molecular mass of that compound. Okay, molecular mass of the compound. Any compound, whichever you are taking. Okay, compound into 100. That's all. Okay, now let us apply the value here. So NH3 only now. So NH3. So here I have taken examples, a mass percentage, how to calculate it. So NH3 equal to atomic mass of nitrogen, what it is? 14 divided by molecular mass of ammonia, it is 17 into 100. Right? How much you will be getting? You'll be getting around 82.35% you'll be getting. Right? Now let us check other three also, because ammonia it is there, urea it is there, ammonium nitrate it is there, and nitric oxide it is there. Okay, come on, let us check each and everything which is the highest percentage of nitrogen. Will be checking. Okay, now the second one, what it is? Urea, NH2 CONH2. So NH2, this is NH2. So urea, usually what we will think, urea only is having more nitrogen compound. Right, now let us check in that how many nitrogens are available. Here nitrogen, actually 2 nitrogens are available. So a molecular mass of nitrogen here, nitrogen, it is 14 plus 14, 28. 28 divided by complete molecular mass of urea, it is actually 60 gram per mole. So here also gram per mole, here also gram per mole. Right, everywhere gram per, because we are dealing with that, what it is, atomic mass, molecular mass, so into 100. So you'll be getting around what it is, 46.6% you'll be getting. Right, you got it. Now the second one, third, next one, ammonium nitrate. Ammonium nitrate is the first compound that we have invented, right? Okay, from inorganic compound. So NH4 NO3. Right, now here the same nitrogen, how many nitrogens are there? Here 2 nitrogens, so that means 28 gram per mole divided by ammonium nitrate molecular formula, molecular mass, it is 80 into 100. Right, now what is the answer you will be getting? You will be getting around 35%. 35%, right? Okay, the last one, nitric oxide. So nitric oxide, how much? That is so simple. Right here, 14 divided by complete. Together it is 30 molecular mass, gram per mole. Gram per mole, everywhere gram per mole. Okay, into 100. Here also gram per mole. Right, now here, so what is the answer you'll be getting? You'll be getting around what it is, 46% only. 46%. I hope you got the clarity. Now here, which is the highest mass, we have to check. Here 46%, here 35%, and next one, what it is, here 46.6%, and the last one here 82% is the highest. Ammonia is actually more source of the plants. Ammonia is the best ingredient for the plants to grow well, right? So nitrogen, wherever nitrogen is there, plants will grow very nicely. So here fertilizers that contribute nitrogen to the soil, which has these richest source, it is nitrogen. Mass on the mass percentage of this, actually ammonia is the highest mass, richest source of nitrogen on a mass percentage basis. So ammonia is the first one. I hope you got the clarity of this, how to calculate the mass percentage. Mainly this concept you will understand. And of course, discussion, 1 mole of an element X has 0.444 times the mass of 1 mole of element Y. 1 atom of element X has 2.96 times the mass of 1 atom of carbon 12. What is the atomic mass of Y? See, they have given the mole of Y, and 1 atom of an element has 2.96 times the mass of 1 atom of carbon 12. So mole of X also they have given. 1 atom of X has this many times mass of 1 atom of carbon 12 also they have given. It is like a puzzle only. Come on, let us check each and everything. Right now, as we are observing, 1 atom of an element X has what it is, 2.96 times the mass of 1 atom of carbon 12. So atomic mass of X, let us identify the first one. So atomic mass of X. Okay, atomic mass of an element X equal to 2.96 times, right, the mass of 1 atom of carbon, 1 atom of carbon 12. So X equal to atomic mass of an element, X, right? So this is actually 2.96 into 12. So that is carbon atomic mass 12. So you will get what it is, X of an element. What is that atomic mass you'll be getting? And be getting around 35.52, right? AMU or gram per mole, anything you can do. Okay, now you have to relate with X and Y. Okay, relate the mass of X and Y. Right. So in that way, 1 mole of X equal to, here they have given the data, 1 mole of X equal to, how many times it is? 0.444 times times the mass of that, the mass of 1 mole of Y. 1 mole of Y. Right. Okay. Now 1 mole of an element. So 1 mole of an element equal to, I just to bring that idea how to deal this. 1 mole of an element. 1 mole of an element is equal to 1 atomic mass. 1 atomic mass. Atomic mass. That is AMU. Right. So 1 mole of an element equal to 1 atomic mass. So for example, hydrogen, 1 mole of an hydrogen has 1 atomic mass, and the same way carbon 12 atomic mass. So in that way, 1 mole of an element is equal to what it is? 1 mole of an element equal to 1 atomic mass, that is AMU. This is very, very important to note down. So through this idea, we can deal this matter. Right now, this is like a puzzle, no, one by one. So the mass of 1 mole of X. So the mass of 1 mole of 1 mole of X, right, equal to 0.444 into mass of 1 mole of Y. Mass of 1 mole of Y. Right. So mass of 1 mole of Y we have to identify. Right now, how to deal this? So here mass of 1 mole just now we found. What is it? Mass of 1 mole of an atom. So mass of 1 mole of an element is a mass of 1 mole of an element. Right. 35.52. Right. So mass of 1 mole of an element, that is equal to atomic mass of an element. So mass of 1 mole of an element, it is actually what it is? 35.52 AMU. I hope you got that idea. Equal to 0.444 into atomic mass of Y. Atomic mass of Y only we have to identify. That is the motto for us. Right now here, atomic mass of Y. Now come to that point main. Atomic mass of Y, we just bring this side. Atomic mass of Y equal to how much? Now this one we for 35.52 divided by 0.444. 444, right? So you will get the answer 80. So atomic mass of Y, it is atomic mass of Y equal to what it is? 80. 80, it's nothing. AMU, atomic mass, right? So AMU here also AMU. So which is the correct option? Let us check with that. You know how to deal with that X and Y always. There is a question with X and Y. Without X and Y, I think we cannot finish this point at all. Always wherever problems are there, no, X and Y will be there. It will present over there, right? Okay. Now atomic mass of Y, it is 80. Option A is the correct option. I hope you got the clarity. Now atomic mass of X, it is 2.96 times that mass of one atom. So X is this one, 35.52 is that one mass of an element. So one mass of an element equal to what it is? One atomic mass. So that is what through that we got that Y mass, right? Right? Yes. Come on, let's go to the next question. The next question, a given sample of pure compound contains 9.81 gram of zinc and 1.8 into 10 to the power of 23 atoms of chromium and 0.60 mole of oxygen atoms. What is the simplest formula? So they have given the grams of the zinc, atoms of chromium and mole of oxygen atoms. Right now, these are all, we have to find out the simplest formula, like what to say, like empirical formula only. This is, we can go for it. Right now here, given mass. Okay, let us write the data first so we will come to know that clarity. So given mass of zinc, given mass of zinc, right? So how much it is? 9.81 gram. And chromium, this is atoms of chromium, right? Atoms of chromium. So atoms of chromium 1.8 into 10 to the power of 23. Right now the next one, mole of oxygen. Moles of oxygen. Right? How much it is actually? 0.60 mole. So this is atoms and this is grams. Yes. Okay. Now for that, how to bring the simplest formula? This is very simple. Okay. Now let us find the mole. Already this one we got the mole. Let us find the moles of these two so that it will be easy for us to identify the answer. So number of moles of zinc, number of moles of, here I just mentioned here zinc, here what it is, the second one chromium, here oxygen, so that it will be orderly, we can write it. So in this point, how to write it? Given number of moles, how to identify? Given mass by molecular mass, no? Given mass by molecular mass. So given mass by molecular mass, how to deal here? So 9.81 divided by atomic mass, here molecular mass or atomic mass. Right now here molecular mass, atomic mass only we can bring. So here 65, right? 65.38 gram. 38 gram per mole. Right. So what is here? Gram only. So gram will be cancelled. So you will be getting around 0.15 mole. right? For the zinc, you are getting 0.15 mole. Now for chromium, how to bring that? Here atoms, number of atoms. So number of moles, how to identify? Here number of atoms divided by what it is, Avogadro number. Simple. So when you are bringing that mole, so here what is the data? 1.8 into 10 to the power of 23 divided by 6.023 into 10 to the power of 23 atoms. So atoms cancel. So this and this also cancel. So what is the answer you'll be getting? You'll be getting 0.30 mole. Right now here for this you are, for the chromium you are getting 30, for zinc you are getting 0.15, and oxygen they've already mentioned in the question only what it is. Here they mentioned in the question only moles of oxygen. Here see in the question only they mentioned 0.60 mole. So oxygen 0.60 mole, and chromium it is 0.30, and zinc it is 1.5 mole. Now which is the smallest ratio? That according to that we can, which is the smallest ratio? Zinc only, of course. So here you will get what it is, smallest ratio. So if you go in that way, for the zinc equal to 0.15 divided by 0.15, so you will be getting 1, and chromium 0.30 divided by 0.15, you will be getting 2. Right, for the zinc, chromium you will get 2. Oxygen it is 60. No, oxygen it is 0.60 divided by 0.15. You'll be getting around how much? You'll be getting 4, right? 4. So that means what is the answer you'll be bringing? Zn it is 1, chromium it is 2, and oxygen it is 4. Zn Cr2O4. That is what I just mentioned here. And this point here, like what to say, empirical formula in that way you can bring. So all the moles you have to bring now, so automatically you will get the idea. So what is the answer you will be bringing here in this point? So Zn Cr2O4. I hope you got that idea how to deal that. This is very simple. Easily you can identify the answer. So which is the correct option? Option A, first option. Okay, Zn Cr2O4. Zn Cr2O4. Option A. Zn Cr2O4 is the correct option. Option B is the correct option. I hope you got the clarity. Zn Cr2O4, how did you get? So data usually if you write the data now, so you can analyze how to deal with it. Number of, how to bring that number of moles. So here given mass by molecular mass. Here number of atoms by Avogadro number. Here already they have given the number of moles, so nothing to worry. So in that least number, that means simplest whole number ratio, you can bring that point and then you can bring this answer, right? Come on, let's go to the next question. Next question, formula of an acid is HXO2. Right now here in this point, HXO2, the mass of 0.0242 moles of acid is 1.657 gram. What is the atomic mass of X? Actually, this is very, very interesting question. Like this puzzle now, what is that X we have to identify? So formula of an acid, it is HXO2. Mass of 1 mole, that is mass of 0.04242 moles of that acid is 1.657 grams. That means what it is, the atomic mass of X. So we have to find the X. For that we'll write the data so that it will be easy for us to identify the answer. So mass of an acid, one by one, let us write it. Okay, mass of an acid. So mass of an acid, what it is? Here what 1.657 gram, right? Number of moles of an acid. Number of moles of an acid is actually what it is? 0.0242, right? Moles. Next one, molar mass we have to identify for this. Molar mass, because formula HXO2. So in that molar mass equal to, that is given mass divided by moles. You will get molar mass, that you know now, right? Okay, so 1.657 gram divided by moles, how much? 0.0242. So you will be getting molar mass, how much? You will be getting around 68.47 AMU, that is gram per mole, right? So molar mass of HXO2, in that X we have to identify. I hope you got that idea. Right now, next one, formula of an acid. This is the formula of an acid, and then molar mass. Okay, I just give that idea how to deal with. Okay, molar mass, that is when we are finding that molar mass is the sum, sum of the atomic masses of all atoms in the molecules. That is what molar mass. So molar mass, it is nothing. It is the sum. I just mentioned molar mass equal to sum of the atomic mass of all atoms present in the molecule, right? So now you know very well what is it, molar mass. Molar mass, it's completely atomic mass combined together. How many atoms are there? According to that, now H2O means two hydrogen atoms, one oxygen atom in that. So all atoms present in the molecule, right? I hope you got that idea. Yes, now this is a very important point to be noted down. You please note down. Right now, come on, according to that, let us apply. So atomic mass of hydrogen, atomic mass of oxygen, atomic mass of X. Let us check. So here in this point, atomic mass, atomic mass of hydrogen. Now this is at this is only no HXO2. So in that atomic mass of hydrogen and atomic mass of oxygen O2, right, and atomic mass of X, atomic mass of X. This is only we have to identify. So this is 1 AMU and this is what it is. Here 32 AMU and X we have to identify. Okay, now here that means we can take it as MX. Okay, X only we have to identify now. So molar mass, let us apply the value here. Molar mass of HXO2. So 1 plus here 1 plus MX plus O2 how much? 16, right? 32, right? Okay, so you will get what it is, 33 mx, right? So 33 plus mx, 33 plus mx, right? So this is 33 plus mx. Now here, what is that we have got that molar mass completely, how much we got it? Here 68.47 we got it, no? Let us apply the value here, molar mass. So molar mass here what it is, 68.47 AMU. Right, now here what it is, mx we can bring it this side. Okay, so here mx plus 33 equal to 68.47. So that means here how do we bring that? Mx equal to 68.47 minus 33. Right, now here you will be getting mx equal to what it is, 35, right? 35.47. So 35.47 directly we can write it 35.5. So 35.5, it is nothing, chlorine atomic mass. Okay, chlorine atomic mass, it is atomic mass, that is 35.5, right? So AMU. Okay, so in that molecular mass or atomic mass there is no minus, right? So that is what. So 35.5 AMU. I hope you got the clarity now. HXO2, X is nothing, HCl O2, right? So this is the compound formula, simplest formula. Right, now I think you got an idea how to bring that. So they are asking X is what it is, 35.5, that is chlorine. You know very well chlorine, that is actually what it is, chlorine. That is actually germ killer also we can use it, chlorine powder and all they will be using, right? So answer it is 35.5 and that is represents atomic mass, it is chlorine, right? Come on, let's go to the next question. Simple question these are all. Next question, what is the empirical formula of vanadium oxide if 2.74 gram of the metal oxide contains 1.53 gram of the metal? See, here this is empirical formula they are asking. No, see, I think we are coming to that point to deal that because it's very, very important question. And yes, it is interesting also. Now, for this, we have to find out the mass of oxygen. That is mass of oxygen, how to identify mass of oxygen. Mass of oxygen equal to actually metals. So vanadium oxide, it is a metal oxide. No, so metal oxide minus metal oxide contains 1.5 gram of the metal. So from there, if you minus only, you will get that mass of oxygen. So metal oxide minus that from the metal. Okay, so here you will get what it is, 2.74 minus 1.53 gram. These both are grams only. These both are grams, given mass, right? So what is the answer? You'll be getting 1.21 grams. So mass of oxygen, you got it, that is 1.21 gram. So metals from that metal oxide, from that metal you are getting. So oxygen mass you are finding. Now moles of vanadium, moles of oxygen you have to identify. So number of moles of vanadium and oxygen. I just put it like this way so that easily we can compare vanadium and this is oxygen. Okay, vanadium, what is that given mass by molecular mass? So vanadium, it is actually a metal. So here given mass by molecular mass, right? So molecular or atomic mass. Here atoms only, no, atomic mass. Vanadium, it is element, right? So here metal, no, what is the metal gram? Here 1.53, right? So 1.53, it is a given mass. So 1.53 gram divided by atomic mass of vanadium, it is 50.94 gram per mole. Right, so you will be getting around how much? You'll be getting 0. moles, right? So this is, that's what number of moles I just mentioned, no? So here you will get 0.0300 mole it is. Right, and the same way oxygen mass also, just now we found oxygen mass. That is the reason I found that oxygen mass for number of moles to identify. That's also given mass by molecular mass. So given mass, it is the number of moles for oxygen, what it is. Here mass of oxygen, it is 1.21 divided by molecular mass of oxygen, it is 16. I mean atomic mass of oxygen, it is 16 gram per mole. Okay, so gram per mole. So here gram and this gram also cancel, this gram and this gram also cancel. So you will be getting around how much? You'll be getting 0.0756 mole. right? Okay, now number of moles we found. Okay, number of moles both we found. This is the number of moles of this oxygen and vanadium, right? Moles ratio. So moles ratio, how to identify? Smallest whole number ratio we can go for it. So ratio of vanadium, which is the smallest here. This is 0.030 and 0.07. So 0.03 only it is smallest. So vanadium it is 0.03 and here also 0.03. So you will be getting 1. And the ratio of oxygen, what it is? 0.756 divided by 0. 0.0. Okay, 0.076, 0756 divided by 0.03. So you will be getting around how much for oxygen? You will be getting 2.52. So 2.52. So simplest whole number ratio here 1, here 2.52. So simplest whole number ratio, you have to convert it into whole number ratio. So that means here vanadium and oxygen, here vanadium 1 and oxygen 2.5. So multiply with the 2 both. So that means you'll be getting vanadium 2 and oxygen 5. So V2O5, vanadium pentoxide. I hope you got the clarity. See, when we put like this, no, easily we can compare oxygen and vanadium, and the given mass we got it from this. Yeah, it is very simple only. Yes, I hope you got that idea how to solve this sum. Right now, V2O5 is the correct option. So option C is the correct option. Come on, let's go to the next question. The next question, determine the empirical formula of Kelvin used in making bulletproofs best. Okay, that is carbon, hydrogen, nitrogen, oxygen. They have given the percentage. Okay, so here carbon 70.6% and what it is, hydrogen 4.2%, nitrogen 11.8%, and oxygen 13.4%. So each one they have given the percentage. So according to that, we can convert into given mass because 100%, no, in that this much percentage, so we can convert into that is a given mass, so that we can identify the what it is, number of moles, given mass by atomic mass, so that we can get that moles. So easily we can identify the simplest formula. What do you mean by simplest formula? That is nothing. Empirical formula. Empirical formula, it is the simplest formula, simplest lowest numbering we can mention. Now, for example, benzene C6H6. Empirical formula of benzene CH. Right. Okay. In that way. Right. Come on. Each one will write the data. So carbon, how much? Carbon, it is 70.6%. Hydrogen, it is 4.2%. And what it is? Nitrogen, it is 11.8%. And oxygen, it is 13.4%. Right. Now here in this point, let us find that the number of moles, because number of moles it's easy to find unless and until we take it as a given mass. Okay. So carbon, number of moles of carbon, hydrogen, oxygen and nitrogen. Okay, so carbon, hydrogen, oxygen and nitrogen and oxygen, right? Last nitrogen and oxygen. Okay, number of moles we can identify. So number of moles equal to here given mass by molecular mass. Given mass of carbon, it is what it is, 70.6 divided by carbon 12, and the same way this is 1 by 4 point here given mass, it is 1.2 divided by 1, that is atomic mass, given mass by atomic mass. Right now the same way here also 11.8 divided by nitrogen, how much? 14, and the same way oxygen, it is 13.4 divided by oxygen 16. Now as we identify the number of moles here, you will get what it is. When you calculate this you will get 5.88 moles you will be getting, and the second one you will get here. The second one, what you will get? You will get that same 4.2 only moles, and then here you will be getting 0.842, and here you will get 0.84. Okay, now simplest whole number ratio, which is that simplest whole number ratio? 0.84. Can we take it as a simplest whole number? Okay, now here here what you will bring, so in this 5.8 for carbon, 5.8 divided by 0.84, and the same way 4.2 divided by 0.84, and then here 0.84 divided by 842 divided by 0.84, and here 0.84 divided by 0.84. So now you will be getting what it is. Here when you calculate now, this you will get a 7, and this you will get 5, right? And this you will get of course 1. So this is carbon, hydrogen, nitrogen, oxygen. So this is what to say, simplest whole number ratio, simplest formula, C7H5 N1, so we can write it N, and oxygen. So C7H5NO, it is a empirical formula. I hope you got that clarity. C7H5NO. So I hope, yeah, according to that, I just brought that idea for you to analyze this question. So the answer, it is C7H5NO is the correct option. I hope you got the clarity to find the answer. So that option D is the correct option, C7H5NO. Come on, let us check once again. So C7H5NO, yes, it is correct. So yeah, come on, let's go to the next question. So option is D. The next question, the hydrated salt N2CO3 H2O undergoes 63% loss of mass on heating and becomes anhydrous, the value of X. So we have to find out that value of X, right? Come on, let us check. This is very simple. When you heat, automatically water molecules will evaporate. So what is that value of X? We have to identify. Right now, this is very simple, right? The molar mass of sodium carbonate, molar mass of sodium carbonate, Na2CO3. So Na2CO3, it is actually 106 gram per mole, right? And the same way, water molecules, molecular mass of water, it is actually 18 gram per mole, but X we did not know. So hydrated salt, hydrated salt, it is actually, we can bring it in that way, 106 plus 18 X gram per mole. Can we bring it in that way? Yes. Okay, now that loss of water due to that heating, right? So how much? It is 63% loss in the mass, right? So loss percentage. So percentage of losing percentage, right? It is mass of water divided by total mass of hydrated salt. Total mass of hydrated salt. This is hydrated salt. Okay, hydrated salt into 100 mass percentage. No, so loss, we can mention loss of mass. Percentage of loss of mass. Right now here, okay, now here percentage of loss of mass, how much they mentioned? 63%, right? So 63% equal to, here mass of water, we did not know, that is 18x, x we just mentioned, and total mass of hydrated salt, it is 106 in 106 plus 18x, 106 plus 18x into 100, right? Got it? Okay, can we bring that idea? So 100, no, so can we bring it in 0.63? So 0.63 into 1 that this cross multiplication 106 plus 18x, right, equal to here 18x. So this 100, now for that we brought it this right now here. So when you calculate these two, so you will be getting around what it is, 66.78 plus 11.84, 11.34, right? So 11.34 x equal to 18x. Got it? Okay, now 18x, when we are bringing that side, so here x and here also x, no, so we can bring it 66.78 equal to 6.66, right? 6.66x. Right now these are all the sums, easily you can go for it. So x equal to, so 66.78 divided by 6.66, right? So you will be getting around what it is, 10.02. So you will be getting x equal to 10.02. So x equal to 10.02. Right now here, Na2CO3 x H2O. So x equal to 10.2. So commonly we can write Na2CO3 10 H2O only. 10 only will be coming, but in the question it has mentioned that. So that is what. So I hope you got that idea. How do we bring that answer? It's very simple. X we have to find. For that formulas, please note down. That will help you. So this is the formula, right? How to bring that formula? This, please note down. Right, come on, let's go to the next question. And by the way, we can go for the option which is the correct option. 10 is the correct option. Yes, option A is the correct option. Come on, let's go to the next question. A 6.85 gram of hydrated salt, that is strontium hydroxide, XH2O, is dried in an oven to give 3.13 gram of anhydrous strontium hydroxide. What is the value of X? Same like last question only. Right now here, directly we can go, because atomic mass they have given. Right now here, strontium hydroxide, right? So here strontium hydroxide, XH2O. So you will get what it is, SrOH twice plus XH2O. So this X only we have to identify. Data is what they have provided, that is 6.85 gram. Right here, 3.13 gram. Now this water, so mass of water, we can go for it. So this is left hand side, it is equivalent to right hand side, no? So mass of water, how do we bring it here? So mass of water equal to 6.85 gram minus 3.13 gram. So you will get around what it is, 3.72 gram, right? So this is 3.72 gram. Now this number of moles only we have to identify. Right now here, this is that mass of water. This is mass of given mass. These are all the given mass, right? Molar mass they have given, right? So molar mass of water, you know very well, right? Molar mass of water. So molar mass of water, it is 18 gram per mole. Right. Now the next point, what it is, moles of water, because given mass by molecular mass. So moles of water. So moles of water, it is what it is, 3.72. So that is, here we got it, no, 3.72 gram divided by 18 gram per mole. So gram will be cancelled. So you'll be getting what it is, 0.2065 mole. Yes, you got it, mole. Right now, next to one, molar mass of strontium hydroxide. Right, molar mass of strontium hydroxide, SrOH twice. So they have given that atomic mass now, all that. So you will get 121.62 gram per mole. Right. Now moles of strontium hydroxide, given mass by molecular mass. Now given mass, what it is in the data I have provided. No, this is the given mass. See here, given mass here it has given now. So here number of moles of strontium hydroxide. So strontium hydroxide given mass by molar mass. So you will be getting around what it is given mass 6.85, right? So here that is the whole mass hydrated salt. So here only this is strontium only we require. No, so 3.13, that is whole completely. So when you are heating, you are losing that water. No, that is what. So water moles we recognized. Now we have to recognize what it is, strontium hydroxide only, right? So that is 3.13 divided by molar mass, what it is 121.62 gram per mole, right? Gram per mole, and this is gram. So gram and gram cancel. So you will be getting around what it is. When you're getting that number of moles of strontium hydroxide, when you calculate it, 0.0257 mole. Right. Water moles also you got it. What it is? Strontium hydroxide moles also you got it. Now X you have to identify. So X equal to moles of water divided by moles of strontium hydroxide. So this is like a like last question only, but something different. So you will get that moles, like what it is, X. So that is 0.2065, right? So this is what a moles. So 0.2065 divided by here what it is 0.0257 moles. So when you calculate this X, you will be getting, so X equal to what it is. When you calculate this, you will get 8. So here X, so that is strontium hydroxide, X H2O is there. No, so X H2O, it is nothing, it is 8 H2O, right? Here strontium hydroxide 8 H2O, right? So this is the correct thing. I hope you got the clarity. Now last sum, and this something variation, the steps actually. This is also another method, right? I hope you got the clarity. So here we are finding the moles. They are also the same, but something different method we follow, right? I hope you got the clarity. So which is the correct option? Option A is the correct option, 8. Right, hydrated salt, that X value, right? So these many sums, I hope you got that idea how to solve, and thank you for watching.